Welcome to Clear Coding. I'm your host, Stephen Clary. Today we're starting a new series on asynchronous gotchas, and this is async gotcha number 1, blocking on asynchronous code. Let's take a look at the code. Blocking on asynchronous code can take different forms. It often looks just like calling getAwait or getResult. It can also look like calling the wait method or the result property. Of course, if you're calling the result property, then you have to be calling a method that actually returns a value. It's important to note that both the wait method and the result property will wrap any exceptions in an aggregate exception. And that's why many people choose to use getAwait or getResult instead of the wait method or the result property. For today's purposes, though, any kind of blocking will cause the problems that we're going to discuss. The async gotcha is in fact blocking on asynchronous code, regardless of what method you use. Blocking on asynchronous code was actually one of the very common mistakes early in the days of async, and it still continues today. It's still a very common mistake even today. But back in the old days, more than a decade ago, I wrote a blog post called Don't Block on Async Code. And this idea was also in my MSDN article on async best practices. In that article, it's referred to as async all the way, which is the best practice, which is the opposite of blocking on asynchronous code, the gotcha that we're talking about today. And like I said, it's still a common problem today. And I think the difference is, in the early days of async, everyone was still kind of learning how to use it, and a lot of developers didn't know any better, and they kind of made the same kind of mistake. And these days, what I've seen more common is that a lot of developers think, well, I know this isn't ideal, but I don't have time to fix it properly, so I'm just going to block on asynchronous code for now, and I'm pretty sure it won't cause problems. And sometimes it doesn't, and sometimes it does. So let's talk about the problems that blocking on asynchronous code can create. There are two problems as a result of this gotcha. Number one is the possibility of deadlocks. That's the one that most people are more familiar with. But another problem that can be caused by this pattern is thread pool exhaustion. And that one's a little bit harder to describe and diagnose. So let's take a look at the deadlock problem first. When an async method does an await, then that await by default captures a context. And this is usually a synchronization context, or it just defaults to the thread pool context. In modern code, if you're talking about a synchronization context, you're usually talking about a UI synchronization context, and that's responsible for resuming the async method on the UI thread. There is another fairly common synchronization context that you may run into, and that is on ASP.NET, on .NET Desktop, so we're talking the old .NET framework. ASP.NET Core does not have a synchronization context. But one key aspect of all of these different synchronization context types, regardless of if you're in a WinForms synchronization context or WPF or a legacy ASP.NET one, all of these synchronization contexts only allow in one thread at a time. That is not true for every synchronization context, but it is true for the ones that ship in the .NET framework. So if you have an async method that is pausing on an await, and that await has captured the synchronization context and is going to use that to resume that async method. And then if the calling method is a synchronous method and blocks on that async method, so you're doing the blocking over asynchronous gotcha, then what that code is actually doing is it's blocking a thread inside of that synchronization context. So for example, if you're on the UI thread in a UI application. And the reason that this deadlocks is because the async method, when it continues after the await, it needs to continue on that context. But that context only allows in one thread at a time, and there's already a thread in that context that is waiting for that asynchronous method to complete. So the synchronous method is blocking on the asynchronous method, waiting for it to complete, and it's blocking a thread in that context. And meanwhile, the async method is trying to complete, it's ready to complete, but the synchronization context isn't free, so it can't actually resume executing. They're both waiting for each other, and then you get a deadlock. So that's the first problem that you have with blocking on asynchronous code. Deadlocks are the most well-known of the problems. The other problem is thread pool exhaustion. And this one's a little bit more complex to explain, but essentially it goes like this. Consider if you're on the server side, and you're running in ASP.NET. So this could be ASP.NET Core, where it doesn't have a synchronization context, so you're not going to have the deadlock issue, but you can still have a thread pool exhaustion issue. And the way that this happens is if you are blocking on asynchronous code, then what you're doing is you're using a thread until that code completes. But most asynchronous work actually requires a free thread pool thread in order to actually complete its work. And so what you end up with is, very briefly, your requests need 2 threads in order to complete. So because your requests, at least for a small amount of time, require 2 free thread pool threads in order to complete, and use both of them, this puts additional pressure on the thread pool. So because of this additional pressure on the thread pool, you can enter into a situation where the thread pool becomes exhausted, and it's extremely difficult for it to make forward progress. I have a blog post that I'm planning to write about that whole situation, but I haven't gotten it up yet. Let me know if you'd like more details on that situation. So let's jump back to the code here. We've talked about the problems with blocking on asynchronous code. Well, what's the solution? The best solution is to not block on asynchronous code, or to do async all the way. And that is, you make your calling code asynchronous, and then all of its callers also need to await. Just as a side note, if you are replacing .wait or .result, double check your exception handling, because that used to raise an aggregate exception and it won't anymore if you're using await. Now, you're going to run into situations here where you can't make things async, right? Maybe this is in a property getter or setter, or in a constructor, or something like that. And sometimes it requires some more refactoring before you can actually make things properly async. Let me know if you'd like a deeper dive into some of those issues. So in summary, we've covered our async gotcha number 1, that is blocking on asynchronous code. The best solution for this gotcha is to go async all the way. I would say the second best solution for this gotcha is to go sync all the way. Because if you're synchronous all the way, then you never need those 2 threads at any point. So you're placing less pressure on the thread pool. But if you must, it is actually possible to block on asynchronous code. You can call getAwait or getResult. The world's not going to end. You are going to place additional pressure on the thread pool. There are some situations, depending on the context your code is running in, where you could hit deadlocks. But if you're aware of these issues, sometimes it's unavoidable. But I would say that's very rare. I've only been in that situation once or twice in the last 10 years. So while I have done it, I think it's best to avoid it if possible. So if you do have any questions, please comment below. If you'd like me to do a deeper dive on why does wait and result act differently than getAwait or getResult, or how do I make things asynchronous that don't want to be asynchronous, or hey, tell me more about that thread exhaustion thing, let me know what you'd like to hear. Thank you for watching. Until next time, enjoy coding.